How's it going, everybody? The voice of Ed Ricker here, and I have the Rotor Riot CL1 budget build quad right here in front of me. This is a new style of CL1 build. They've had some CL1 builds in the past, but anyway, this is analog FPV. They have some HD models too that incorporate the DJI Air unit, but this is just the budget build, so this is $200 if you buy these components unbuilt. If you want it pre-built for you, it's $300. Either way, an amazing value because each component bought separately would be well over $300. So to get this for $200 and also have a kit that you know everything's going to work together and build, maybe it's your first quad or maybe it's an additional budget quad that you want to build, this seems like a really great option. So you basically get all the components into a box, and they don't really give you instructions. So I'm going to use part of this video to help teach you how to maybe put together the frame, installation of some of the components, and some BetaFlight snags that you might run into in order to get this working properly. Also, at the end of this video, I'm going to tell you how to win this exact quad. Yes, I'm giving away another drone. So here we go. In the kit, you get your choice of hype train motors. I went with the Vanover series. These are for 6-cell batteries that I run. The motors are like $27 each. So, that's already a great value to get them in the kit. Just specify what kind of motors you want. The frame, by the way, is a CL1 frame. It's budget, but it seems durable. The carbon fiber is very thick. The arms are very thick too, width-wise as well as thinness. They give you a Runcam Phoenix Oscar Edition. They have the supplied mounts for that, as well as for the VTX antenna, just a lollipop there. Did not come with props. These are my choice of props. These are just HQ 5x4.3s. This is also my extra strap because they only gave you this thin one. The way I fly, the way I crash, I really need to strap in with 2 battery straps and one that's a little bit more robust like this. All right, let's talk about the guts. So we have the Transtech F7 flight controller. Now the flight controller comes with the pinout sheet. However, I have it oriented this way, so if you can read, we have our yellow camera wire right here, video in. We have our white VTX wire, video out. And I originally got those mixed up because usually yellow always means video, and then white would mean something like smart audio, but no. Smart audio on the VTX, the Rush 500 milliwatt transmitter right there, that's kind of in the back, has a white video wire, so don't get that confused. If for some reason it's different on yours, just make sure that you look at the pins here and make sure that they say what they say. VBAT power right here with the VCC pins soldered here, so just the top 2, not the bottom 2. So, and you could use the bottom 2 because 5-volt powers the Rush, but I'm actually using full VBAT power and then ground for the VTX. So this is how you power the VTX. And then the way that I have the camera powered, you could power it through that 5-volt pin on the flight controller very easily, just fine. However, I'm actually making this slightly cleaner and I'm powering it from the Rush VTX. There's actually a 5-volt and a ground on the pinout for the Rush VTX straight to the camera. Really easy. I'm using the TX4 and RX4 UART pads here for the UART camera control. So one thing that's really cool about the Runcam Phoenix Oscar Edition is it features not only joystick camera control but also UART camera control. So you select your UART 4 Runcam device in BetaFlight, and then you can use these 2 pads, TX4 and RX4, straight over to here to your camera to control your camera with your radio. Very cool. A little known feature right here, it says CH. That CH pad right there, if you bridge them, you cannot use a VTX power switch in BetaFlight. So you can assign basically a switch on your radio to turn on and off your VTX, which might be really cool if you're flying around people and you want to power on real quick and you don't want to blast someone out of the sky because you're on the similar or close video frequency. It comes default bridged, so if you want to use this feature, you have to not only program that in BetaFlight, but also remove this bridge on the flight controller. Just wipe the solder clean, and then you can use it. You see right here on the side, these are your RX wires. They give you an option for a FreeSky XM Plus or a FreeSky RXSR, and since RXSR has telemetry and it's very, very small, I wanted to use that. So I got the RXSR. And this is how you do it. Your TX and your RX1 is for your RX and TX pads on the RXSR. 5-volt powers the RXSR, grounds it, and then I'm using TX2 for SmartPort. So SmartPort will enable our telemetry on the RXSR, and again, you just select that in BetaFlight, and you're good to go. So basically, UART 1 is serial RX, UART 2 is SmartPort, UART 3 is ESC telemetry if you want to use that, UART 4 is camera, RunCam protocol, UART 5 is VTX TBS Smart Audio. Now, since I've already built this, I can't really lift the flight controller off too much, but you can see I've snuggled all of the wires underneath. So everything that is soldered comes around and then underneath. So the VTX comes around and then underneath. The camera goes around and underneath, and then the RX comes around to here for the RXSR. So underneath is your 4-in-1 ESC. We have our motors all going to it this way, and this is the way that they had it mounted in the pictures, where the VBAT plug or the VBAT pads are facing toward the front. That may not be necessary if that's not how you want your XT60s to come out. However, they had that in the picture, and I wanted to be safe and just make sure I was doing it in accordance with how they've tried and true tested it. So anyway, that's pretty much how we have it right there, wired up with our motors, and then the connection from the ESCs to the flight controller is right there with a harness. When you first get the flight controller, it gives you a harness, but it just ends with a bunch of wires. They don't have it connected on both ends because obviously they don't know exactly what kind of ESCs you're going to be using. Basically, I'm using these forceps and shoving in these wires according to how they are in the ESC harness. Nothing is exactly mirrored here. Even though they're the same type of harness, the wires are crossed back and forth. Motors 1, 2, and 3, and 4 are a nice succession here, 1, 2, 3, and 4. But on the ESC, it's actually 2, 4, 1, 3. So you can't just have the wires go across, straight. You have to make sure that the pinouts are indeed, where they're supposed to be. Another really cool thing they give you is a 1,000 microfarad capacitor right there. So I have it just soldered right to the positive and negative. Make sure that you got the positive and negative polarity of this corresponding with your pads, because otherwise you might blow up your capacitor if you have them backwards. And on the back there, that's how I've mounted the RXSR, right on top of the VTX. I'm hoping that's going to be okay. That's how they have it in the picture, and I think it's going to be okay, but you just got to make sure that this isn't going to overheat and blow up your RXSR. I have ruined a couple RXSRs in the past just because of shoddy soldering. So since it's such a small board, this might be susceptible to heat, and I'm hoping this is going to be okay. I do like to run 500 milliwatts on this whenever I can. That RXSR has antennas mounted underneath and up the arms like this. This is Joshua Bardwell's style of doing it, and I really like it. And whenever I did free sky in the past, I would always mount them this way. So the antenna come out the sides, underneath the arm, and they get mounted with a zip tie like this, and then put shrink wrap, and then heat the shrink wrap up and make sure this is nice and tight. So as long as these are horizontal with the rest of the quad, and horizontal with the ground and the props, you're not going to have a prop strike. And I think it's much better than sticking them out the back. Sticking them out the back, a couple of reasons. First of all, sticking straight out and like up, you could run the risk of a prop strike, especially if you hit like something that's really low, maybe a tree branch, leaves or whatever, could push that RX antenna down and into your props. That would not be good. Doing it this way, I've sometimes broken the zip tie just because of a hard crash or whatever, but I've never actually gotten the antenna stuck into a prop, so that's really good. Second reason, they don't actually give you antenna tubes or shrink wrap to actually help you get it out of this mount, like stick it up like that in an effective way. A couple of the challenges that I ran into with this build, first of all, when I plugged in my ESC and I got it going and I went into BetaFlight for the first time, I did a check to make sure that all my motors were spinning properly, and unfortunately, they were not. These two motors were switched, and these two motors were switched. Now, I'm not just saying spinning the wrong way, I'm saying that the flight controller had them reversed in its little mind. So you gotta make sure that you can remap the resource of the motors in the CLI commands. I'm gonna link to an article that teaches you how to do that, and just make sure that you follow that. Check the video description for that. Also, make sure that if the motors are reversed, which means they're spinning outward like this, because the standard would be this, you know, spinning inward to the camera and inward to the VTX antenna. Well, if you're spinning the opposite direction and you do the test arming in BetaFlight with your props off in the motors tab, make sure that you've selected that the motors are indeed reversed in the configuration tab. If you don't do that, this thing is going to go whoop, and it's going to spin, and it's going to just like go nuts. Make sure that you got that option checked. The first time I flew this, I did not have it checked, but luckily I had my laptop with me, so I was able to fix that. Also in BetaFlight, in the receiver tab, make sure that your inputs are labeled appropriately. This ship's different from what I need, which is TAER, which is your radio control input setup. If that's wrong, then you're going to have a quad that's going to flip out when you try and throttle up. So just look in the lower right and you can see the preview window, and make sure that once you've bound this quad to your radio and you start moving the sticks around while the quad's powered on and also connected to BetaFlight, everything is moving the way it's supposed to move. You know, when you roll, when you pitch, the quad on the screen is moving appropriately. A few things that I have adjusted in BetaFlight. First of all, with BetaFlight 4.0.6, which is what this flight controller shipped with, the motor and ESC protocol was like 1-shot, 125 or something. So I'm using D-shot 1200, works great. I've turned on ESC sensor. That way we can get telemetry, ESC, BLHeli 32-bit ESC telemetry. Accelerometer on or off is really up to you. I don't fly, you know, any stabilized mode, so I usually have that off, but I'm gonna keep it on for now. However, the arming degree I have at 180 degrees, which allows me to arm at any angle that the quad is in, and that's helpful if I end up crashing and I want to try and flip over or something. I have labeled my craft name, my ham radio license call sign, KN4SOL. Receiver type is the S-Bus receiver right here. And I've turned on telemetry, air mode, OSD, anti-gravity, and dynamic filter in the other features list. Remember, if you do use accelerometer, make sure to calibrate it on the desk, and then make sure it's working by moving the quad around on your desk with your props off. This is also a way to test the motors with, again, your props off, and just make sure everything looks like it's good to go. In power and battery, I've lowered the minimum and warning cell voltage a little bit. I've never been able to get an actual amperage display out of here. I have amp draw OSD usually, and for some reason it just didn't work this time around. I keep having a 0 amp draw, so I'm not sure what's wrong. If you guys have any ideas, let me know, but I'm using the ESC sensor, and because I'm wired up with ESC telemetry, so anyway, just let me know. When you enable expert mode in BetaFlight, you can also go into the failsafe options, and here I have throttle as hold as opposed to auto, and that's just something I learned from Joshua Bardwell's video in the past, as well as a 0.5 second guard time for stage 2 activation after signal loss. So make sure to set up your failsafes on both your radio and here in BetaFlight. On your radio, you want to select no pulses after you bind your quad. All the flights that I did were on stock PIDs, although I did adjust my rates. These are my rates: roll 1.55, pitch and 1.55, and yaw 1.22 for RC rate. Super rate left alone, and then RC Expo is 0.3 across the board. Finally, I have my modes all set up. I just have arm, beeper, and flip over after crash. Those are the 3 switches that I use the most anyway. And then my OSD is pretty simple. In the footage you'll see in a little bit with some test flights, I did have the amperage, but again, it wasn't working. It was stuck at like 2 amps, even though I was full throttling and stuff. So it definitely was not showing proper amp draw or accurate amp draw. However, I have my battery voltage, I have my call sign, and I have my RSSI value all there in the bottom, kind of spread out. That's just my preference for OSD. I don't like to go too crazy and too complicated with OSDs. One thing about the camera is I'm not a huge fan of the 3D printed mount. I understand it's a micro camera, they had to get something that fit, but if you crash really hard, the mount can actually slip up and down along the standoff. They're just being held by friction here. You could maybe glue it down or something, but then you're kind of committing to that particular camera placement. So just be careful if for some reason your quad all of a sudden feels really weird. Maybe it's because your camera got all jostled. If you want to make the UART camera control option work with the Phoenix Oscar Edition, before you solder the 2 pins here, you've got to power on the camera while they are shorted. So that means connecting the two and just like hanging them off to the side. So if you solder these or you somehow clip them together with something metal, you have shorted the green and the red wires here. Then you power on the unit, and you can see in the FPV feed on your desk, on the top it'll say joystick control or remote control. Every time you power on the camera or power on the entire system with these two wires shorted and off the board, you are initiating a change in the setup of the camera. Once you see the proper mode you want to be in, then you unpower, you desolder, or I should say de-short the two wires here, solder them on accordingly to the flight controller, then power on normally, and you've got your remote control or joystick control. With the Rush VTX, they gave you a nice long pigtail here. Well, it looks like you got an extra pigtail because you don't have to use it, at least if you're going to mount it like this. With the Lollipop just chilling here with the mount, you can actually plug it in right there without too much of an extreme bend to that UFL connection. You don't want to bend this too much. Usually you avoid right angles and stuff, but right now that's not too bad. Another thing I'd suggest when you're building this is only put on the foam feet last, because if you're going to be putting on tape like this, as well as maybe wiring your RXSR antennas and stuff, it's going to be a lot easier to do that without having your rubber feet already installed. I installed these like as one of the first steps and then realized, oh man, I got to tape down these motor wires. The Vanover motors did not come with blue Loctite on the mounting screws. To make sure that the screws don't wiggle out from oscillation and vibration, put some blue Loctite on those screws, just a little bit, and that way you have less of a chance of these screws wiggling out and eventually losing a motor, which is not good. It's happened to me before. In the future, I may use some damaged props, cut off the blades, and then use the blades and tape them over these ESC wires. That's not what they show in the pictures that you do, but that's going to actually prevent you from cutting your motor wires from a prop strike. If a prop gets bent, it slices right through. Since I wanted the UMA grip to be pretty wide but still have access to these screws, I just took an X-Acto knife and I cut little wedges out of the UMA grip, and that way I can still screw in this screw here without damaging the UMA grip. If this starts losing its grip and it becomes less sticky for plastic surfaces like batteries, just wipe it with some water. Be careful though, don't drip that everywhere. But if you just clean it off with some water, you should be just fine. Some people say lick it. I don't suggest that. I like the simple design of this, and I like that everything can be wired underneath to keep it nice and clean from a view of the top. That way when you're putting your battery straps on, you're not going to be snagging wires and stuff, and it's just a cleaner build. You look at this and you can really see exactly where everything is wired in, and it makes a lot of sense. You also have lots of space. It's a very tall frame, so even though that stack it has a little bit of a height to it, you still have tons of room for your battery strap, and tons of room here. I mean, if you wanted to put something else, a Bluetooth module, or I don't know, whatever you need, a beeper. All right, so here is the bottom plate, and you see that the bottom of the bottom plate has these little protruding threads. There's 8 of them, and there are 8 long screws that come in the pack, and then you have these smaller screws here. These are for the standoffs. These are for affixing your arms to the plate. So with the plate, you have the protrusions of the threads on the bottom. So on top, we have it here. We're going to put an arm and orient them correctly. Arm, arm, and arm. And they meet in the center, square them up, and then you take the little sandwich plate here, and that goes right on top, just like that. Now you screw them in. That is our frame, and this is oriented properly. So now, up is really up. That was actually the bottom. So we're correctly oriented now. The build took me about 3 hours, and then maybe another hour to set up and troubleshoot a few little issues that I had. So not too long. I think if I were to do this again, though, I could probably do it within an hour or two. It's a simple build, but doing it the first time without an instructional manual definitely posed a few challenges. All right, here we are. We're at the park. Got some trees, got some lines. I have test hovered this and flown it a little bit, but I have not done any tricks like flips or rolls or anything. So looking forward to checking this area out with the CL1 budget build. All the DVR footage is coming from the Fat Shark HDO2s along with the rapid fire module. For my radio, I'm using the Jumper T16 Pro. And I'll be using a GoPro on the chest mount for my stick cam right here. All right, we got this plugged in. Let's get this going. All right, so the amp draw on the right, I don't think that's actually accurate, but let's see. Yeah, the amp draw should be much higher if that was actually truly the current. I'm just flying this around. The camera's very sharp. I may bring down some of the sharpness on the camera, but it feels smooth. I don't detect any oscillation. So this is just gonna be cruising. I'm just cruising underneath the trees, flying overhead. Yeah, I think what I'm gonna do is change the sharpness on my camera. So let's see. Can I do this? Remote mode. Okay, I got my video settings? No. Enhance. There we go. Yeah, we're gonna lower the sharpness to like 3. Let's try that. Return. Save and exit. Let's see if that looks any better. So let's do a couple inverted things here. The stick is a little bit twitchy. You know, this is just stock 4.0.6 BetaFlight, which I don't have a whole lot of experience with. I keep most of my quads at 3.5.7, which was the last time before some of those other features were implemented into BetaFlight. But this feels good. Let's do a couple rolls. Okay, so the rolls are amazing. Wow. No bounce back. That's perfect. Flip is great too. So the quad's tuned really nice, and if you learn to fly using these settings, it's going to be amazing for you. Now, since I'm used to a quad with slightly different settings, this is kind of tripping me out with I don't know, the PIDs. I mean, I guess I like maybe a little bit tighter of a quad and a little bit more gummy of a center to the sticks and everything. But this feels pretty good. Now, I do see a little bit of the frame, you know, the upper right, upper left, but it's not horrible. Yeah, I'm not a huge fan of the stubby, I guess. It's just a little too close to the frame for my taste. Hold on a second here. Rapid fire keeps clicking over. But yeah, I mean, it feels locked in for BetaFlight 4.0.6, but it's just a little bit different in terms of handling than what I'm used to. Let me do a power loop. Wow, there we go. That was a power loop. Battery got pretty low. Of course, that was a big punch out, but I actually had a little bit of a battery warning. I'm sure you probably couldn't hear it in the GoPro, but there was a little beep going on from the low battery warning. So we definitely had a little bit of a sag there. And 21, wow, okay, 21.6. Yeah, we really have already eaten up this battery pretty well. Let's land and put a fresh battery in. So for 6S, I like to end at about 21.7 volts.
Well, I was trying to do one of those Vanny rolls. I got stuck in a tree. Oh my God, I was barely in it.
All right, well, that is the Rotor Riot CL1 build. Pretty cool little quad. Great value for the money, especially if you build it yourself. Then you have a nice little afternoon project, but also you're getting it for $100 cheaper. And like I said, these components all together would be over $300 if you bought them all separately. It's a really cool concept to have these ready to build kits, and it takes away some of that frustration and time that you would spend researching components, making sure they're all going to work together. Sometimes that's half the battle. So thank you to Chad of Rotor Riot for sending this to me to review. I'm going to be giving this quad away, by the way. So in the comments section, type hashtag CL1 budget build, just like that, and tell me where you like to fly FPV quads. And if you don't own one, where would you like to fly an FPV quad? In 2 weeks from this upload date, I'll pick a random winner and I'll post it in the comments as well as the video description. Thanks so much for watching, everybody, and until next time, happy flying.